More than 200 million people are affected by floods and droughts each year in the Asia-Pacific region, far higher than any other region.
Bangladesh, Myanmar, Thailand and many other countries are still experiencing terrible flooding on a regular basis. This flooding disturbs lives and livelihoods and really brings cities and industries to a grinding halt.
The region also commonly experiences droughts, particularly when the monsoons fail. These events are happening more regularly than in the past, with unacceptable consequences for the poor, especially women and children.
After a major drought or flood event, it may take many years for the lives of the communities to get back to normal.
Across the developing world, we still lack flood control technologies that are cheap and perform well for the long term. Traditional approaches to flood management have focused on shifting water from the often poorly utilized floodplains that in the dry season could be used for improving livelihoods.
What makes this such a challenge is that it's just not enough for governments or donors to be spending money to fix the immediate problem. We need scientific support on how to invest in solutions that are worthwhile over the longer term.
Underground taming of floods for irrigation, or UTFI, works just like a bank account, only for water and at the scale of a river basin. Water is deposited in wet times and withdrawn in the dry. Over the dry season months, water resources are typically stretched the most. Farmers draw upon whatever supplies are available to irrigate their crops, while cities and industry draw upon water in specific localities for their daily needs.
In wet years, when all of the water storages fill up, the river cannot cope with the flows. Water spills out over the banks and the floodplains get inundated. UTFI is best suited to addressing this particular form of flooding.
Applying UTFI would mean setting up numerous low-cost recharge basins in upstream areas. During the rainy season, excess water flows into the basins and infiltrates into the ground, adding to reserves and restoring the water table. Downstream flooding is reduced and high-value infrastructure and other assets are protected. During the dry season, the water stored below ground is easily retrieved to boost irrigation and livestock production.
What's novel about UTFI? Well, firstly, it's never been done at the scale that's needed. Secondly, it requires clever design and operation. Thirdly, it creates interdependence between communities located upstream and downstream.
But there are also risks. On a technical level, UTFI could transfer pollutants from the rivers into the underground or lead to overfilling of the aquifers. UTFI is also not yet geared up for flash floods, so applying it for these purposes is probably inappropriate. On an institutional level, if the upstream communities do not engage due to lack of knowledge or incentives, then the system will become run down and the benefits not realized. Experience tells us that all of these risks can be foreseen and managed.
UTFI is a very innovative idea. It is a mix of technology, existing natural conditions in river basins, and people working together to overcome the problems associated with climate variability. It could be a win-win situation for everyone involved.
The UTFI idea emerged as a spin-off from a research project conducted in the Chao Phraya River Basin in Thailand.
Through this project, we learned that the major flooding events in Bangkok could be averted. 28% of the flows to the Gulf of Thailand can be harvested and used for intensifying agriculture. This could be done without significantly impacting the freshwater used and marine ecosystems.
Current UTFI work is focusing in the South Asia region, where the needs are highest.
The Ganges Basin is not only one of the largest and most populated basins in the world, it is also subjected to frequent devastating floods in all the 3 countries that fall within it.
The region is vast, and the first step was to work out how to pinpoint the hotspots for interventions.
It's remarkable We have discovered that about 30% of the watersheds in the Ganges are very good candidates for UT5. This could be a very effective way to start to control some of these disastrous floods.
However, before practical UT5 application can really get underway, more research needs to be done.
Amongst other things, we think that UT5 could provide a cost-effective subsurface alternative to large surface dams.
Demonstration sites, guidelines, tools, and protocols must be developed to enable the technology to be more broadly applied across flood-prone Asia.
We are starting to understand where it could work and how it could work, under which conditions. We're starting to understand the costs and benefits of it and the trade-offs of it. Now what we need is the engagement of decision makers and investors.